Hello, and welcome to Electronic System Design and Integration for 2025. This is a 100% coursework module. There's two assignments, 50% each. The first part, you're going to design and build a metal detector, and the second part, you're going to build a circuit of your choice. Now, the coursework is equally weighted at 50% and 50%. And the deadlines are published on Phaser. I'll let you look those up, but actually I do have them here. So the 27th of February for the first one and the 21st of March for the second one. The submission is in the form of a report, and it will be graded entirely on the report. However, there is a large lab presence. We have 3 hours per week. And the general format of the teaching, it's in Lab 8, by the way, the general format of the teaching is that the first hour is dedicated to learning new stuff, and the second and third hour are dedicated to you working on your electronic designs. Now, we use Multisim, probably not the best simulator in the world by any stretch of the imagination, but it is a good entry level, and it has some good simulations in there as well, as far as transient analysis, AC analysis, and so on are concerned. And it's all in one package, so you can export your design once you've simulated it out to Altiboard, and then you can build a two-sided, three-sided, four-sided, however many side PCB that you want. Now, part of this module is that it's hands-on. So when you finish this module, you're useful to industry, because they could sit you in a corner and say, design something for us and produce that PCB. And you would understand the pipeline from the circuit diagram that you take from reference, going into a drawing of the circuit inside Multisim, a simulation of that circuit, an export out to Altiboard, whereby you would then design the printed circuit board itself. It doesn't stop there, of course, because after that, we're going to send it away to PCBWay. PCBWay are going to make the printed circuit board for us in a couple of 3 days and send it back to us. And then, of course, we can populate it with components. Now, one of the biggest issues that we find inside the labs is students understanding that a capacitor, for example, doesn't come in one size. A resistor doesn't come in one size. And this is one of the critical things in going from a circuit diagram to a PCB. You need to have an understanding of the component itself, which means that there's a lot of background research on the ratings of the component, the dimensions of the components, and so on. Once you've got those nailed down, another part of the assignment is what we call the BOM, or the bill of materials, and you're expected to put a cost against the design that you have. So you can imagine that I'm your manager. I would look at something and think, well, how come this person can build me this PCB for £1, £2, whereas this person's PCB is £100? It doesn't make sense. So they've probably made a mistake in the way in which they've ordered things. Also, you can't actually buy a single component usually. You have to buy them by the 100 or the 1,000. So it'd be interesting to see what you come up with when you cost those as well. So as I said before, the first assignment is a metal detector. It doesn't have a particularly long range, but it's quite a bit of fun. We give you a kit. You solder it all together in the soldering room to get some hand skills. You can see the pick and place machine inside the soldering room as well, and we've got microscopes and so on in there to help you do the soldering. So a bit of fun just to start with. You get to keep those kits, by the way, so a little souvenir for you. And after that, what we're going to do is we're going to take the circuit diagram that comes with the commercial kit, and we're going to put that into Multisim ourselves, simulate it, produce a printed circuit board for it with a few criteria that I'm going to give you. So as I come around the room, I'll give different people different requirements of that board. So, for example, where the handle goes, where the output coil goes, where the LEDs go. I'll ask you to put different designs on the back so that I know it's unique and I know it's yours. The second part, a circuit of your choosing, well, that's a difficult open-ended one, but I have a big long list of the types of things that people get working really well. Digital dice are one example, little radios are another example, filters are another example, but we'll speak about that as we go through the course. Can you do this remotely? No. No. If you don't turn up to those lab sessions, then you may well be on the wrong course. This is a very, very much hands-on, practical skills experience type of module. If you attend those, because there's 3 hours per week, and that's Thursday 11 till 2 through the spring term. If you attend all those sessions, you will pass with flying colours. You have my word of honour, my guarantee on that. If you start skipping things, try and catch up, trying to do it remotely, trying to work it out for yourself, you will flounder. You will flounder because there's a lot of subtleties, especially in the first couple of weeks where I bring you up to speed on multi-sim, and that really is almost holding your hand. I'll do it on the whiteboard, projected on the whiteboard. I'll do one step, you do that step, and we carry on until everyone's kind of got the hang of it. There's usually a couple of GLAs and another academic in the room, so there's plenty of support in those early times in the first couple of weeks. Once you can run, as it were, learn to walk, and now you can start to run, then things become a lot more relaxed and a lot more exciting from your point of view, because you've got the freedom to work on your own material. But that doesn't generally happen until about week 4, week 5, until you're fluid with the simulators and the electronics which underpins it. So if you haven't been in Lab 8 before, it's in the Networks building on floor 2, and it's beautifully equipped with all of the modern things that you'd expect to find inside a fabrication lab. So a pick and place machine, which is a robot that puts the components, surface mount ones, but puts the components onto a board ready for the solder flow. Most of what you'll do inside the lab prototyping is just going to be through hole technology. The reason being is because you can see it. Some of the surface mount devices are smaller than a piece of dust, so clearly that's going to prove limiting if you're trying to prototype something. When you do prototyping, which you probably will on your second assignment, you really want to check whether it works before you commit to making the PCB. Various ways that you can do that. You can do what we call rats nesting, which is just solder it together as it appears on the desk with no board or anything. Another way is to use breadboard, that you push the components in. It's not the most reliable stuff in the world, but it's certainly quite fast. Veriboard is probably the most practical and robust way of prototyping. And once you've prototyped on Veriboard and it works fine, it works as you expect, then of course you can consider the commit to the printed circuit board. Now, printed circuit boards, despite what you might think, are very, very cheap indeed. So something the size of a post-it note or something will cost you about £4 or £5 each. And the economies of scale obviously start to cut in there. So if you're mass producing something and you want 100, they get much, much, much cheaper. But we also discuss the transition from the electronic design over to what you need, the information that you need to send to the PCB manufacturer for them to be able to make a successful printed circuit board. Unfortunately, they don't care terribly much, so if you make a mistake in giving them that information, they'll still make your board, but your board might be upside down, back to front, with half the tracks missing. That's not their problem. All they do is they manufacture exactly what you tell them. So at the end of this, just with this module alone, not the rest of your MSc, but just with this module alone, you would certainly be in a position to apply for a job at a small to medium enterprise electronic design company. Multisim might not be the CAD tool that you use, but it will certainly prepare you for the other type of CAD tools you'll come across. And the pipeline, this is the important thing. So how do we go from, and ultimately it's a circuit diagram drawn on a piece of paper, how do we go from that circuit diagram to the final product that we hold in our hand that works? I think you'll agree that's quite a skill, and that's a skill you're going to acquire in the next 10 weeks. And that's a skill you're going to have in the next 30 hours worth of tuition. Okay, I look forward to seeing you in the lab. We have a lot of fun. I take videos every week and upload them for no other reason, just that it's a nice record, and people can refer those videos back to their families and so on, and show people what they're doing. So it's a fun module. Okay, I look forward to working with you, and I'll speak to you soon. Bye-bye.